Hello, my name is Demir, and I'm going to talk about deep learning and its applications to computer vision. So what exactly is deep learning, commonly abbreviated as DL? Deep learning is a subset of machine learning which attempts to mimic the human brain in order to learn material. I say mimic the human brain as in it uses neural networks, which we'll talk about a bit later and get into more detail about them. So deep learning has become much more popular in recent years due to the rapid performance increase in GPUs. And another thing I didn't put down there, but the increase in VRAM on said GPUs. On some of the models I've trained, which are relatively small models, they take 10 gigs of VRAM during the training process out of the 12 gigs. And 10 gigs of VRAM was not a thing just a couple of years ago. But the performance issue has been the historical main limiter of training a deep learning model. And deep learning can extract features in a data set that are important on its own with minimal intervention from the programmer, which makes it a very powerful tool in AI. So unlike other algorithms that we've talked about in class, deep learning can figure out what is if you got say you got a picture of a cat and you want to train a bunch of cat pictures, the algorithm itself will figure out what is the pattern essentially in the picture instead of you having to tell it that this is look for the cat's nose, tail, whiskers, whatever. The algorithm itself will figure it out, so it's less programming intervention. And since deep learning extracts features from the data on its own, it requires a huge amount of data to be fed into the training process for the method to be viable. I actually trained a face tracking model on myself, and I'll show that at the end of this presentation, but I took 120 pictures of myself from various angles, and I did a bunch of augmentations using the albumentations Python library, and I turned that into 5,000 pictures, and I trained it on that. So it takes a lot of data, and that's a very small amount of data. If you look like Tesla's autopilot, that takes hours, thousands of hours of video data, image data, all kinds of data in order to successfully get an accurate autopilot that they use currently. So what is a neural network? Neural networks mimic the brain by having layers upon layers of neurons, all connected by synapses. The networks learn by assigning weights to each node in the network and apply backpropagation to update the weights during training. So the difference between a neural network and a deep neural network, is a deep neural network can have many, many hidden layers, while a regular neural network can have maybe 1 to 5, maybe. But a deep neural network can have many, you can have hundreds, 150, 200 plus hidden layers. And that's where the term deep comes in. And backpropagations, say you've got features essentially that are starting on the left side here, and then the output is here, right? And when you're training this, your features get broken down through your network and come up with an output on the outside. If you have, if it's not accurate, when it's training, it figures out it's not accurate, it'll go in reverse and update the weights on each one of these nodes, and then retrain it using that. And that's how it learns, per se. So what is computer vision? CV is a subset of AI that allows computers to see the world in a sense. Computer vision is all around us. If you've ever used Google Lens or driven past a Tesla, then you have interacted with computer vision. Applications of CV are endless, from self-driving cars to detecting certain diseases early on while they are still treatable, like Alzheimer's. There's actually a study being done right now of using computer vision to detect Alzheimer's early on. And the Alzheimer's can be treatable if you can detect it early. But since a lot of people don't detect it early and it's really hard to detect, then nobody ever gets it done. But now there's actually there's people using computer vision, scanning brain data or brain images and figuring out whether they have Alzheimer's or not, or early onset Alzheimer's with a fairly high accuracy. And convolutional neural networks, which are CNNs, provide a scalable approach to image classification and object recognition tasks, leveraging principles from linear algebra to identify patterns within an image. So since an image is essentially like a 1920 by 1080 pixel matrix multiplication is heavily used, hence why GPUs greatly accelerate training time, as they are good at doing just that. If you look at well, any GPU really, it's meant to display an image. And images are essentially matrices of pixels. So they're trained just for doing that. They have thousands and thousands of cores, all with a single purpose of displaying an image. And that task makes them very good at training ML models and whatnot. So we'll talk about the types of computer vision. I'll go into depth a little bit more afterwards, after this slide. But there's image classification, object detection, semantic segmentation, instant segmentation, and regardless of type, nearly all of them use convolutional neural networks. That's the backbone of computer vision. There's a lot more types down here, but these are the ones that I'm most familiar with. So we'll start with image classification, and its sole purpose is to classify what is in an image. You feed it with images and their associated labels when training, so you'd have to take a picture of like this cat, and then you'd say that it's a cat. And you train it with that image and label that it is a cat. And it takes thousands and thousands of pictures of different cats, all kinds from like different angles, which you can use augment during the training process, like with that Albumentations library and whatnot. And you get a classification like 82% cat, 15% dog, 2% hat, 1% mug. All it does is tell you like this is what's in the picture, right? And then you got like object recognition, which is how, well, partially one of the main deals of self-driving cars, which is somewhat the same concept, but it'll draw a bounding box, which is this little yellow like box around what it thinks is the vehicle or whatever the class is. And the goal of it is to teach a computer to recognize what is an image like we do as humans. So instead of just one single thing, you look at the picture and figure out what is in that entire picture. And deep learning is applied as, once again, convolutional neural networks are generally used to do this. It takes thousands of images of each class of object to train, and a class is like a bicycle, car, person, traffic light, so on and so forth. I've got a working example that I have, that I'm building for a personal, well, not building. I used YOLO v5 algorithm, which is available on GitHub, and I'm taking that, modifying it, and I'm going to use it for my personal project. And I'll go and show that at the end of this if I have a little bit of time. But while it's not perfect, it gives a good demonstration of the live object detection, my algorithm. In practice, they're usually pretty perfect, or very high accuracy, I should say. But then you got semantic segmentation, which segments an image into different classes based on what is in the image. It doesn't consider the number of objects within the same class. So this is like, it's a bit like image classification, as in it sees a person, right? And then it doesn't tell you like there's person 1, 2, 3, or bicycle 1, 2, or 3, whatever. It just tells you that there's a person and a bicycle, right? And we'll get into instant segmentation, which is pretty much semantic segmentation, but it tells you like you got person 1, person 2, person 3, or in this case sheep 1, 2, and 3. And it segments an image into different classes based on what is in the image, identifies individual objects instead of multiple objects within the same category, is applicable to self-driving cars, medical imaging, etc. And I am pretty sure, I'm not 100% sure, I couldn't find it anywhere, but I'm pretty sure this is how Google's Magic Eraser on the Google Pixel phones work, is by instant segmenting things in the picture, and then you can erase it, and then it uses some other AI to build a background from behind that. But now that is the end of my PowerPoint, and I will get into the what is it called? The object detection algorithm that I built. Well, I didn't build. Took from the YOLO v5 that I'm working on. Source 0. It takes a little bit to start up, but once it starts, it's pretty cool. And I got this to run on GPU acceleration. And as you see, it will segment what is on my desk. It thinks the microphone is a mouse, but it's size point. But it detects what's on my desk and spits out as an accuracy on it. And if you go into like here, I don't know, it's not going to probably show up, but it shows you like there's one person, my hand, a keyboard, and the monitor being shown, and it tells you that as it's going through live. And this also works, it's hard to start or stop for whatever reason. Yeah, there it is. This also works on like a YouTube video, so if you have like people walking in Times Square, it'll do it live as the video is playing, and it'll demonstrate, or it'll detect all the people within an image. And I've had it up to like 40, 50 people detected, a million cars, traffic lights, people's purses, backpacks, all kinds of stuff in it. And my other one that I did that I'll show is going to be the face detection one, which I have to set up this camera to look at me real quick. And then open up the Jupyter notebook that I have been working on. Both of these are what I've been doing what I did over Thanksgiving break. And I used GPU acceleration to train it, and it took a couple minutes per image. Well, actually it took like 30 minutes to train the 5,000 images. And I just have to get to the imports that I need and then run it. TensorFlow. I had saved the model and trained this prior to it, so it didn't take forever. And then we load the model. Well, of course, you gotta love Jupyter Notebook. Start the kernel. Got a little bit over time, but we should be fine. Where is TensorFlow? There it is. Don't need that. I need, where are you? This Numba import CUDA just dumps the VRAM that's on my GPU currently that was used in the other one. And then we import the model. It gives you a bunch of notices about the GPU, and then theoretically should pop up with a window. Yes, loading cues, there it is. So now whenever I move my face, it tracks my face essentially. And I got this to work. I also trained it with, if I put my hand over my face, it doesn't detect the face, although it's having something weird with the blinds behind me, but as soon as I do it, we're back to normal. And this was trained on 120 images of my face. That is then turned into about 5,000 with the image augmentations. But yeah, that is about it on deep learning and its applications in computer vision. This is actually what I want to do with my master's and would love to get a job in, because I find this very interesting and it's really fun to do. But yeah, thank you guys for listening.